Hey guys, Mr. Walker here. Welcome to another math lesson with Mr. Walker. Today we have a new kind of goal for us. We're going to be moving away from some of the models and things that we've been using, and look at how we can explain equivalent fractions using a tape diagram and a number line. Now, a tape diagram obviously is something that we've used in the past, and a number line is also something that we've seen before. But so far when we've been doing equivalent fractions, we've been using kind of like that area model, right? So we're moving away from that, taking a look at the tape diagram and number lines, and just kind of like exploring some other strategies that we can use to find equivalent fractions. So in my mind, it's pretty cool, but of course I'm a math nerd, so I always like learning about different strategies to kind of help solve the same problem. So that's definitely what we're jumping into today. So we're going to work a little bit with that, and then you guys are going to practice it on your own, and we'll have some fun. So really all you need for today is something to write on, something to write with. So once you have that ready to go ahead and click continue and we'll keep moving on. Alright guys, so I'm going to start by just drawing a tape diagram here. Okay, so I'm just going to come across, draw that, common kind of rectangle that we're used to seeing. And this tape diagram is going to represent one. Okay, just one hole. So that's kind of what I'm just representing here. Now I'm going to split this tape diagram into halves. Okay, so I'm just going to split it right down here in the middle, and I have kind of represented halves, right? So this would be one half, this would be two halves, and I'm just going to go ahead and color in one of these halves for right now. Not perfect, went out of the lines a little bit, but you get the idea. Alright, so I have one half represented here on this tape diagram. Now what I'm going to do next is I'm going to decompose this a little bit further. Since I started with a half here, I'm going to decompose it a little bit further to make fourths. Okay, so I'm going to decompose into smaller pieces. So let me get a different color to do that in. So if I were to split this guy again here, and split it over here as well, now I've made fourths, right? One of these squares would be a fourth. So if I look at my shaded portion again, I had one half represented here, and now I have 1, 2 fourths. 2 fourths, okay? And if I were to kind of write that as a multiplication sentence, I could say that 1 half is equal to 1 half times 2, right? Because we split it in 2 there. We multiplied it. We made twice as many pieces, and that's equal to 2 fourths. Okay, so these are equivalent fractions right now. They're going to live in the same place on that area model. Let's go to eighths. Let's see what happens if we try eighths. Again, I'm going to draw different, or get a different color here, and let's see. We'll have 1, 2, 3, 4, 5, 6, 7, 8. So now I've divided that into eighths, right? And let's look at our shaded portion. What's still shaded in here? We have 1, 2, 3, 4 eighths. 4 eighths, okay? If I were to write that as a multiplication sentence, kind of like I did with this guy here, what would that look like? Starting at 2 fourths, how would I say that 2 fourths is equal to 4 eighths? What would that look like? All right, if I said 2 fourths times 2, 2 times 2 is 4, 4 times 2 is 8, so I made an equivalent fraction. I had broken those pieces up again into more pieces. I had multiplied them by 2, and I just realized I have kind of like a Christmas theme going on here. I like it, with my Cheeto Puff cheese here on the side. So anyway, sorry, I get distracted. But anyway, you can see that we can make equivalent fractions using a tape diagram, right? We were to find 1 half of this, and then 2 fourths and 4 eighths, which is all the same thing. They are equivalent fractions, and we use the tape diagram to help us find that. So now I'm going to get rid of some of these fractions for a second. Now, just to kind of compare this a little bit more, take this a little bit further, if I was going to label each one of these benchmarks, each one of these units here, so if I was going to start right here on this tape diagram, I would say I have 0 halves, or 0 fourths, or 0 eighths, right? Because I have nothing, right, if I'm right here. If I go one step further, I have 1/8. Right here I have 2 eighths. or 1/4. If I went another step further, I would have, let's see, 1, 2, 3/8, 3/8, and nothing else. It's not really equivalent to anything else. But if I went even one step further, I would have 1/2, which is the same as 1, 2, 3, 4/8, which is the same as 2/4. And then I could keep going. So this would be 5/8. All right, 1, 2, 3, 4, 5/8. No other equivalent fractions there, but if I went to the next one, that would be 3/4 or 6/8. And no halves, right? And then here would be, let's see, well, it would be, I'm sorry, here, this green line here would be 7/8 and nothing else. And then this last one here would be everything else. 2/2, it would be 4/4, it would be 8/8. Okay, so you can kind of get the idea using this tape diagram of where all of these fractions live in comparison with one another and what fractions are equivalent, stuff like that. So it's just kind of a cool way to lay it out. But let's transition now into the number line side of things and see what that looks like. All right, so here I'm going to represent a number line down here at the bottom. I'm just going to draw a straight or straightish kind of a line. All right, and I'm going to start with 0, right, because that's where our 0 is, and I'm going to end here with 1 because I'm representing one whole. So I'm still representing the fraction. I'm just doing it on a straight flat line, okay? Still the same kind of effect, the same thing going on. So if I were to go to 1/2 here on the number line, it's going to be right here, okay, halfway through. I'm going to split it into 2 halves, right? And if I were to decompose that number line again into fourths, let's go for a different color here, and let's say let's split here and here. So this means that this would be 1/4, and then 2/4, which is the same as 1/2, right? They're going to be in the same place there. And then this would be 3/4, and then 1 would be the same as 4/4. Okay. And now if I came back and decomposed it again, multiplied it by another 2 to get to 8ths, I would go here, 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 and here. All right, so I would have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8. Okay, so I have found some equivalent fractions. I have labeled all my different fractions. I've decomposed into different fractions using this number line. So the same thing that I could do in the tape diagram, I could do in the number line. It's just representing it two different ways. If you think about the way you decompose it, right? If I'm moving from halves to fourths, I'm multiplying that by 2, right? So I'm splitting it between like 2 people now, so I have to divide it in half again. That's how 2 gets to 4, and so on and so forth. So you can kind of think about how decomposing relates to that multiplication like we've been doing in the past. Let's expand on that thought for a second, on the multiplication and how this all ties in by looking at a different example. All right, so I got another number line here. In this number line, I'm going to partition or break apart into thirds, okay? So if I were to start with like 0 down here, right, 0/3, and then 3/3 all the way at this end, which would be the same as 1. This would be the same as 0, this would be the same as 1, so let's do 1/3, 2/3, 3/3, okay? It looks pretty even there. So this would be 1/3, all right, 1/3 here, 2/3 here, 3/3 would be the same as 1 whole. So let's say I wanted to take one of these thirds here, this third right here, and I wanted to, let's say I wanted to split it into 4 equal parts. I wanted to decompose it. It's kind of a hard color to see. I'll go with Vikings colors, so I like it. I'm going to decompose this into 4 equal parts. Okay, so that means in between this 0 and 1/3, I want to break this into 4 equal parts. So I could still do that. And I would just do 1, 2, 3, 4. 1, 2, 3, 4, right? I decomposed it into 4 equal parts. That's easy enough. So could we figure out what that equivalent fraction is now? How would we figure out what all these points are here and what is the equivalent fraction going to be right here if I were to split that third into 4 equal parts? Well, since I'm decomposing it into 4 equal parts, I could think of it as 1/3 is equal to 1/3 times 4, which is equal to, well, 1 times 4 is 4, 3 times 4 is 12. So this would be worth 4/12. 1/3 and 4/12 is the same fraction. It's the same amount. They are equivalent. So then I could also use that to say, well, this must be 3/12, 2/12, and 1/12. All right, so I know, using my multiplication down here to help me out, I know what each one of those fractions is worth if I were to decompose that 1/3 into 4 equal parts. And just like in the area model, we're composing units to make larger units. We're kind of breaking things down, right, to figure out an equivalent fraction. But you could also kind of think of it this way, the opposite way. If I were to group those 4/12 together, that'd be the same as 1/3. It'd be like when we were grouping the numbers previously to make other fractions, either multiplying or dividing. Either way, we can still make equivalent fractions, okay? Hopefully I'm not breaking your head too much. So let's just look at one more example before I drive you guys crazy, and we'll see if we can start to make this all make sense. All right, last one. Unless, of course, you guys want. All right, last one. Unless, of course, you guys want more. I got no problem doing more math. That's kind of what I do. So let's take a look at, let's divide this number line into fifths. So let's say this is 0/5, right? We're going to start all the way at 0, and we'll bring it up here all the way to 5/5, because that would be 1 whole, the same thing, right? So let's see, fifths, 5 equal segments here. Let's try, that'd be 1, 2, 3, 4, 5, right? So this would be 1/5, this would be 2/5, 3/5, and 45/5. 4/5. So I'm just making sure you're paying attention, just making sure. This would be 4/5. Okay, cool. So I have decomposed this number line. I've broken it into fifths. Okay, so that's easy enough so far. Now, what I'm going to ask for us to do, and I'm going to have you guys try this out first, is I want you guys to decompose or break down, or however you want to look at it, decompose 2/5 this time, 2/5 into 6 equal parts. Okay. In the previous example, we were just decomposing 1 part or 1 unit. This time we're decomposing 2. So I have 2/5. I want you guys to decompose that into 6 equal parts. Brainstorm for a minute. Think about it. Think about how you might want to attack that, and then show me your thoughts, and then we'll come back together and discuss. All right. So if I was going to break 2/5 into 6 equal parts, right? 2/5 would be here, from here to here. To make that into 6 equal parts. So far right now it's broken into 2 equal parts, so that's okay. So if I was going to break it into 6 equal parts, that means I'd have to do 3 and 3, right? So let's see, I'll do here and here, and I would do here, and let's say here. So now if I look at this, I have 1, 2, 3, 4, 5, 6. So I've decomposed those 2/5 into 6 equal parts. Okay, easy enough. I'm cool with that. All right, so let's think about this for a second now. We took each one of these fifths here and multiplied it by 3. 1, 2, 3. We split it into 3 groups, or 3 smaller fractions. We decomposed it, right? So if I were to say we have those 2/5 and we multiplied it by 3, and that would give me 6/15. So I could say that this is an equivalent fraction here of 6/15. I could also say that we took those 2/5 and split them into 6 equal parts. 1, 2, 3, 4, 5, 6, right? So we can multiply by 6 to get 12/30ths Okay, 12/30. So that would be another equivalent fraction. Okay, and now based on what we have here, if this is 6/15ths, right? 1, 2, 3, 4, 5, 6, 6/15ths. If we counted backwards, 1, 2, 3, that would be 3/15ths. I can even keep going forward and say 6/15ths, 7, 8, 9/15ths, and then keep going, so on and so forth. So you can see how we can make those equivalent fractions either by decomposing, and when we decompose, when we're breaking it into smaller pieces, we're actually multiplying it because we're getting more pieces. So you can multiply it by whatever you were decomposing to find those equivalent fractions as well. So hopefully I thoroughly confused everybody and made this really difficult. No, that's totally not my goal. You're going to practice with this some more. You're going to get some good opportunities to practice and to see some examples of this. So I want you guys to take your time, make sure you understand it. Go through that problem set, really, draw out those number lines, draw out those tape diagrams. Get a good handle on this, because this is going to be something that not only are we going to keep seeing, but it's something that's going to come in really handy when you're either trying to make equivalent fractions or compare fractions or anything like that. So take your time practicing with this. Please reach out if you have any questions, comments, or concerns. And I appreciate you guys watching, and we'll talk to you soon.